Hey, in the previous video, you have seen that Word2Vec is cool and works nicely for lots of different tasks. However, in this video, we will raise some doubts and we will see that especially for word analogies task, everything is not so smooth. Just to recap, the Word2Vec model is trained in an unsupervised manner. It means that the model just sees the corpus, let's say Wikipedia, and it trains on this to obtain word vectors. Now, the word vectors that are obtained have some nice properties. For example, if you take the vector for king, you subtract the vector for man and add the vector for woman, you will get the vector, and the closest word to this one will be queen. And this is awesome, right? So it looks like the model could understand some meaning of the language, even though we did not have this in the data explicitly. But, well, let us look into more closer details, how this search of the closest word is performed. So you see that we have this arithmetic expression, and then we maximize cosine similarity between the result of the expression and all the candidates in our space. But we exclude 3 candidates from this search. So we say that our source words, so let's say king, man, and woman, do not participate in this search. And well, you know what is this rather important trick that is usually omitted in descriptions of Word2Vec model. However, let us see what would happen if we looked into this honestly and if we performed the maximization in the whole space. The picture shows what would be the closest neighbor to the arithmetic expression in case of the honest search. The color shows the ratio. The names on the left correspond to different categories of analogies. It is not so important for now. Let us look into the last one, which is called encyclopedia. The example about king will fall into this one. So what we see is that when we do king minus man plus woman, we get some vector, and in most of cases, it will be close to the B vector, which is king here. Also, in some cases, it can be close to A prime vector, which is woman here, but never to B prime vector, which is our target queen vector. So you see, actually in let's say 90% or 80% of different analogies, we find the vector which is close to B vector instead of the target B prime vector. Well, you know, it somehow ruins a little bit the picture that Word2Vec understands our language. Now, I want to dig a little bit deeper into it. How can it be that when we exclude A prime and B vectors, we nicely find B prime vector? But if we do not exclude them, we end up with B vector. So I think that this picture can shed some light. The thing is that the shift vector, A prime minus A, seems to be close to 0. So this plus woman minus man is close to 0. It means that when we apply our arithmetic operations and we try to find the closest neighbor, well, the closest neighbor is actually B. But once B is excluded, the next closest neighbor is indeed B prime. And we say that, okay, king is excluded and queen is found. Okay, so maybe we can just use much more simple methods to do this. I mean, can we just take the nearest neighbor of B and do not apply any arithmetic operations at all? Well, some people tried that, and they said that for one particular category of analogies, the plural category, which is apple to apples is the same as orange to oranges, just the strategy to take the closest neighbor of B results in 70% accuracy. So you see, this is a really high accuracy, very similar to what we could see for Word2Vec in the previous videos, and just by a very dumb approach. This is another visualization of the same idea. So this comes from a really recent paper, and it says, let us split our word analogy examples into several buckets. So for example, those analogy examples where b and b prime vectors are similar will go to the right. And those examples where b and b prime vectors are not so similar will go to the left. Now, the blue bars in this slide show the accuracy of Word2Vec for every bucket. So you can easily see that the blue bars are high on the right and low on the left, which means that Word2Vec works really nice in those analogies where b and b prime are similar, and it works poorly for those more complicated tasks where they are not similar. Now, let us see what are those more complicated tasks. So, let us study what types of analogies covered in this diagram. There are actually 4 main types of analogies. For example, you can find actor and actress in the very bottom line. This is kind of the same thing as our king and queen example. But we have much more here. So first we have some morphological examples. We have inflectional morphology, which means that we can just change the form of the word, like orange to oranges is the same as apple to apples. Or we can have derivational morphology, which can also change the part of speech, like bake to baker is the same as play to player. Now, we have lots of different semantical analogies. For example, we have hypernyms there. This would be, for example, peach to fruit is the same as cucumber to vegetable. We have many more. For example, the nice one is about colors, like blood is red and sky is blue. And you know, there are many different options, and this is not so easy to build this dataset, so we need some linguistic expertise. Anyways, once we have this, can we look into how Word2Vec performs for different analogies? And can we compare Word2Vec with a very simple baseline? The baseline would be just to take the closest neighbor to one of the query words. So here we go. Each line here corresponds to some analogy example. For example, one line would correspond to apple to apples is the same as orange to oranges. Now, the left point for every line is the performance of the baseline. And the right point of every line is the performance of Word2Vec. So it means that horizontal lines show you that Word2Vec is no better than the baseline. When the line has a high slope, it means that Word2Vec does a good job. So you see that for inflectional morphology, which is an easier task, Word2Vec performs well, and for derivational morphology, all the lines are horizontal. Now, what happens with semantic analogies? Well, this is a nice picture. So the thing on the left is about different types of analogies, and most of them have horizontal slope, which means that Word2Vec doesn't work for them. But 2 lines, red lines, have high slope, and those 2 are the examples about genders, like man to woman is as king to queen, is as actor to actress, and so on. And the picture on the right is about some named entities, and the 3 red lines are about countries and capitals examples that are really popular in Word2Vec descriptions. For example, Moscow to Russia is the same as Paris to France. So you know what? Those very famous examples are kind of the only ones that actually work with Word2Vec. I mean, they are not the only ones, but it looks like things are generally worse in random for different tasks. Okay, so the takeaway of these insights would be that you should be very careful about hype that you see around. So it is always nice to dig into some details, like how is evaluation performed, what would happen with a little bit different tasks, and see whether some methods provide some good or bad solutions. So to me it looks like Word2Vec works nicely for word similarity task. For example, if you have some application where you need to understand that tap-off and faucet are really similar and should be placed into one category, then Word2Vec is your choice. But you shouldn't be blinded and you shouldn't think that it somehow solves the language or provides the solutions for word analogy task in all the cases. So it works sometimes, but not always. And this is a nice question to have further research on it. Okay, in the next video, we'll talk about some extensions of those techniques like Word2Vec. We will see what are now current state-of-the-art approaches and what are some open source implementations that you can use in your applications. So stay tuned and you will get some practical advice what models to build in your cases.